Hi everyone, my name's Rob from RobOps, and today we're going to be figuring out hosting for our MMO and exploring what we'll need to do to get this game off of our laptop and into your fingertips. As a quick refresher, in the last video we touched on the progress we had been making on the MMO we're building, covering the world editor, the prop placer, and my sad attempt at 3D modeling. For the astute viewer, you would realize that MMO stands for Massive Multiplayer Online Game. And currently, we're not massive, we are certainly not multiplayer, and unless you count playing by yourself, we are not online either. So in this video, we're going to try to address this. We're going to see if we can host our game server on AWS and serve our client directly in the browser. This is actually a very important test because a big tenet of the game design that we had from the outset is that it needs to be able to run in the browser. If it doesn't, we could be wrapping up this series earlier than expected. So for our infrastructure, we're going to be running both our server and our front end on pods in an EKS cluster. We could have simplified things and ran our front end out of an S3 bucket, but because we have open socket connections and because we have some dynamic behavior with Cognito, I think it was just easier for us to work with Docker files instead of static files saved to S3 buckets. For authentication and authorization, we're going to be using Cognito. For game state persistence, we're just going to use a simple DynamoDB table. And the compute layer, like I mentioned before, is going to be running on EKS. We're going to be fronting all ingress traffic with a CloudFront, and we have a network load balancer that's going to distribute traffic into our cluster where ingress-nginx will pick that traffic up and route it to the according pods. Now, if you're interested in actually how the cluster was set up, I'm not going to actually focus on that in this video. If you are interested, I have a 40-minute video where I go through all of the steps to set up the cluster from scratch. And I also have a publicly available repository with all the Terraform that you would need to get this started yourself. So there are a few things that I'm legitimately concerned about before we start. First, I'm actually not sure this is going to work. The reason why Steam is such a popular platform for game makers is because they provide their client that's optimized for gaming. Our project is going to run in a Chrome browser, which is, a multi-purpose tool used for many different purposes, one of them being games. Second, I'm not sure what permission boundaries we're going to need to explore. Obviously, we need our EKS cluster to talk to DynamoDB, but we also need to make sure all of the permissions make sense. And finally, I don't know what the minimum host size will need to be to achieve the same performance that we have running this thing locally. Obviously, I'm not trying to break the bank with this project, and so if I do need very large hosts, this could be trouble for our project. So if we hop into the code base here, we have our game development repo, and you'll see we have an infra directory and a Kates directory. If we open up the infra directory, we'll have an EKS subfolder along with our modules. And if we open up the main.t, or the readme rather, in the infra folder, you'll see effectively this infra directory is going to be deploying our EKS cluster, our Cognito user pools, DynamoDB, Ingress, etc. Everything we talked about in the tech stack. Now, an important, sequence of events that we have to do is we first apply at the root level of the infra directory, and that's going to do our Cognito along with our DynamoDB tables and kind of like all of our more persistent infrastructure. And then the folder here under EKS is going to be all of our compute layer. And so this is going to set up the network along with our EKS cluster, our managed nodes, and we're running a single T3 medium, which again is our hypothesis that we hope we can run this because it's a relatively small machine. That should cost us about like $2 a day to run. And then we have kind of like our ingress-nginx and the Helm chart that handles that, and then our OpenID connect rules. And so this is applied secondary on top of our persistent infrastructure, and that's what will create our overarching infrastructure. And by the end of it, we should effectively have an API endpoint at api.robopslive.com, which will be responsible for contacting our server. And then we'll have app or game.robopslive.com, which will basically launch our front end, which has kind of our hooks into Cognito and allows us to run the game. So now that we're in our repository, we're going to look at our runbook. And like we mentioned before, we need to navigate to the infra directory And here is where we have our Cognito and DynamoDB and things like that. Now, this is already applied, and the reason I already applied it was just because I didn't want to overwrite any of the old files that I had, or old entries in the database. But what I'm going to do is then navigate to the EKS folder, and then I'm going to run a Terraform apply. And this is going to generate the plan for spinning up our EKS cluster. And as you can see, we have 33 resources to add. And like I was mentioning at the beginning of the video, api.robops.live and app.robopslive.com is where we're going to be able to access both our front end and our API endpoint. So I'm going to click yes here, and we're going to kick off the apply. And this should take about 15 minutes to apply, and we should have our infrastructure at that point. Okay, so our apply just finished, and we've added 33 resources, just as our plan had kind of subscribed or prescribed. And you'll see we have two different CloudFront domains, one for our API and one for our app. And we have the domains of those applications. We have api.robopslive and app.robopslive.com. And so this is effectively where we're going to be serving our front end out of app, and then we're going to be hosting our server at API. And we'll also have our OIDC issuer URL along with a few different details in our output. So now what we want to do is just verify that we actually have the infrastructure in Amazon. And so I'm just going to switch over to our console view. And as you can see here, we have our EKS cluster, MMORPGs-EKS. And if I just go to like our EC2 console, for instance, I should see a single running T3 medium instance. And there it is. And if I go like to inspect our network, we should be able to see basically our network for this project. And so you can see here we have production VPC at the 10.1 address, and then we have our default VPC over here. And so all of the infrastructure looks good, but the next logical step, well, first it would just be, like what happens when I go to app.robopslive.com. And as you can see, we get a 404 not found, but we get an nginx redirect or an nginx forward. And so effectively this means nginx is probably running, but our app is not being served. And so believe it or not, this is actually expected. We haven't actually deployed anything to our cluster yet. And so if I just switch back to our code view here, I'm going to go into our cluster. I'm going to leave this window open and just create a separate one. And I'm going to set up my kube context. So I'm going to go AWS EKS update kube config cluster is actually I think it's name is MMORPG EKS, and then the region is US East 1. And so this is going to set up my kube control. And so as we can see, it updated the context. So if I go get pods in all namespaces, we're going to see what actually is running in the cluster. And we get effectively an empty EKS cluster. So it's just running the kube system primitives, so the core DNS, kube proxy, and the AWS Node API. And then we also have our ingress-nginx. And so this is responsible for what served us our 404, which is a positive sign. But obviously we need to now deploy our front end and our server to this cluster. And so if we go into the README here and we go and scroll a little bit down, after we've applied our EKS changes and we just run this command to just get the nodes. I got the pods, but it's the same thing. We need to do a few things. And the first is, now that the cluster is up, we have some of the cluster parameters that we need to pass to enable connectivity. And so we're going to do that, but effectively we need the OIDC provider ARN as well as the OIDC issuer URL. And so once we have those, we have to reapply our Terraform so that our Cognito and our DynamoDB are able to communicate with our cluster. Once we do that, we'll be able to actually apply our Kubernetes YAMLs to the cluster to create our namespaces and deploy our server and our app to our cluster. Okay, so now we're going to follow the commands here, and so we're going to apply our namespace YAML. And so here, if I just run k-apply, here it's going to create our namespace. And so we'll wait for that. And so now if I go k get pods -n MMORPG, we'll see there's no resources in this namespace, but it does in fact exist. And the other thing we're going to need to do is add a secret. And this secret is going to pull the user pool ID and the app client ID, which is going to be required for our app to communicate properly with Cognito. I'm just going to paste this in, and this should create our secret. And so here we can see secret MMORPG server created. And so these were 2 steps to kind of prepare our cluster for the next step, which is actually building and pushing our files to our cluster. So in this next step, now that our cluster is ready, we need to build the images. And so to conceptualize the game architecture, there's 3 artifacts, right? We have our front end files that we package up when we run, like a npm build, and that's just going to package up our JavaScript and put it into a package that we can execute on the pod. We have our server, which is just effectively an API framework, fast API that is going to be running also on a pod. But something unique about this project is we have our game binary. And so the game binary is how we package our game file. And so the way that we're running it is we package our game file and then we push it or reference it in our front end. And that's how it's actually going to play in the browser. And so the first thing we need to do is build the game binary. The second thing we need to do is reference that binary in our front end and then build that front end. And then, in parallel, we can also be building our back end. And so we have GitHub action workflows that do each of these things. We have like client export, and then we have the build and push the front end workflow, and then the server. But as noted here, we have to build the game binary first. And so we're going to prepare these artifacts, and then once they're ready, the final step is actually deploying it to the cluster. So to do that, we're just going to run our workflows. And then if you go into here, so GitHub run client export, and this should kick off the build in GitHub to build our game binary. So I'm going to do the same for the front end and the back end. And then once those are all finished up, we'll come back and start the next step. So the jobs have all finished, and I've verified that the images have been successfully pushed to ECR. And so the next step is to actually start to deploy to our cluster. And so in order to do that, I'm just going to apply my K8s directory. And if you look at our K8s directory, it's a collection of Kubernetes objects or deployment YAML for our front end service, along with our ingress and secrets and things like that. And so if we go like that, we should now bring up our app and API pods. And so as you can see here, we had a bunch of resources deployed to our cluster. And then if I go k get pod -n MMORPG, and I just watch this endpoint, I should see a front end pod and a server pod come up. Awesome. So it looks like we have our pods running. So I think now we're actually ready to do a smoke test and see if this actually works. And so to test this end to end, we're gonna go over to our Chrome tab here, and we're gonna just go to app.robopslive.com. And as we can see, we are serving our front end. This is the Next.js app, and as you can see, it's being served from RobOps Live, not on localhost like we were doing in the last video. And so I've created an account already, and because I didn't nuke Dynamo and Cognito, the account is still valid. So what we're gonna do is click sign in here, and we're going to see if we're able to load. So here's the game engine. It's going to be bootstrapping all of our game files. Doesn't seem to be working, but it does look like we loaded in some of the UI here, but we don't actually have the interface. So we're going to check out why that's the case. All right, we're back. So part of the issue was the Cognito secrets that we added. So the client and the user pool information weren't actually getting to the cluster. So we're going to try to re-sign in now and see if we're able to get it here. Okay, so we've warped in here and things look a bit better, but we don't have any ground or any sort of terrain. And if I look in the console, it looks like the chunks are having a trouble loading in. But the positive thing is we are able to interact with our NPC. So let's go figure out what's going on with the chunks. Okay, so attempt number 3 here. I think if anyone has worked with anything in a browser before, I think cores was the issue here. It was just blocking our chunks from loading in. And so as we load here, I'm hopeful that we should see our world load in as well. And look at that. It looks like we are live in the world. We have our NPC. We can talk. We have our objects we can interact with. And if we run down here, we can see our NPC and our bank. See, the bank works as expected. We have our goblins over here. We have our forest. So look, this is pretty good. Actually, this is very good. I think performance-wise, it appears to be working pretty well. I wonder if I log in on another character here at RobOps Live, and I go and use this other account I created, what the performance would be like. This would be supporting 2 concurrent players. So I'm just gonna create a female character. Click accept and see that they've warped in. And yeah, we can see, I mean, the character is appearing as the default, but that's more of a game bug than anything else. I can go hello, and say hi, my name is Hero. So it looks like we are actually online here. It looks like the performance is okay, and it also looks like we'll be able to kind of continually build with the CI/CD we set up for this project. So I think this is all good news. I think we are ready to kind of continue iterating on the game now that we know that we can actually scale it in a way that we can make regular releases. So that's awesome. So just coming on here to wrap up, I think today was a very successful experiment, or at least a very reassuring experiment, that our browser-based MMO development can continue. Based on the concerns from the beginning, can we actually push this game binary into a browser and have it served? The answer is yes. We did run into a few hiccups. We actually ran into a lot of hiccups off the video that we had to solve ahead of the 3 or issues or so that we've encountered on the new cluster. But I do think we've proven out that we can run this game on the browser. In terms of the connectivity, we ran into some issues with some of the secrets being passed to the cluster, but we were able to easily resolve those. And then finally, something that I'm actually quite happy about is the T3 medium that we had was able to sustain 2 concurrent users. which is great. And so we're going to continue this series. This was like a major milestone just to get it in front of people. If you are watching, you can try to go to the game now and create an account. I'm going to keep the cluster up. It's going to cost me about $150 a month to do so, but I think it's important to have a product available so you can dog food it and play as you develop it. And so if you are interested, check it out at app.robopslab.com. It's not going to live there forever, but it's there now. I think in terms of what next for the game, I'm trying to build kind of like an end-to-end quest that the player can kind of like walk through various components of the game and get familiar with. And so in our next update, it will probably be the end-to-end test, the end-to-end quest that's available in the game. But I appreciate everybody watching. I'm also going to be posting my Discord below if you want to chat and share ideas about what you think the game should turn into. So thanks again. Thanks for watching, and I hope you have a great week.